Hi, my name is Elijah Andrews, and this is my lab report for Lab 1 Constant Velocity. The purpose of this lab was to compare the observed motion of a rolling object and compare it to a computer model. The principle that we were focusing on was Newton's second law, which is net force is equal to change in momentum over change in time. My results initially aligned with my computational model, but later deviated due to friction and other errors. Newton's second law just says that the net force on an object is equal to the object's mass times its acceleration. This can be rewritten in the velocity update formula, which can then be transcribed to the position update formula. Procedure for this lab: first we set up a camera and a measuring stick for later reference in Tracker. Then we rolled an item across the frame and measured the distance traveled using Tracker software. And here you can see my Tracker analysis. I track based off of the front part, and you can see the system is the cart and surroundings is everything else. I calculated the initial velocity for the formula by approximating it with change in x over change in time for a small change in time, and got 0.741 meters per second. For GlowScript, I set it up with the initial position and velocity from my recording, and also set up the delta t to be the same as the recording, which is 1/30th of a second. I then plugged in, set the net force equal to 0, and set up the position update and velocity update formulas. And here you can see the model in action. The GlowScript modeling shows that the object's motion wasn't actually perfectly consistent, and its velocity actually slows down towards the end of the time. There are a few different reasons why this may have happened. The most likely reason why this happened is friction that led to the net force on the system not actually being 0. Other potential errors include incorrectly tracking the direct middle of the black part of the cart, or potentially making rounding errors when plugging information into GlowScript. I picked a traditional axis for my tracker. However, if you, for example, flip the axis so that positive x was to the left, then the slope of your position versus time graph would be negative. And the model shows how the object would react if there was no net force. So our deviation showed there was a net force. And however, we can't really guess the number of different pushes and pulls. We can assume gravity and normal force, but beyond that, we can't really be sure how many different things are pulling at it. And thank you for your time. I appreciate you watching this video, and hope you have a good day. Bye.